life's short, so I wanna live real. But how's it supposed to feel?
Hey guys, welcome to the part 3 of the C programming course. In this video, we will learn how to take input from the user. Then we will see about the ampersand operator. This is mentioned because it will be an important topic while taking input. Then we will learn all the mathematical operators in the C programming language. Then we will see what is the order of precedence of these mathematical operators. Then we will discuss about the relational operators. Then we will discuss about the logical operators. Then we will discuss about unary operators. After all these topics, we will come to the challenge questions. Pause the video while solving the challenge question. Then we will discuss the solution of the challenge. Without any further ado, let us begin the video. Today we're exploring how to talk to our computers in C language. Specifically, how to get them to listen to what we tell them. Who can guess what that involves? Right. User input. We want our programs to ask us questions or accept information. That's where our friend Scamp comes in. Let's break down this code together. First, we need some tools. So we include the style.h library. Think of it like a toolbox with special functions for talking to the user. This main function is our program's starting point. Everything inside here happens when we run the code. Now, we need a place to store what the user tells us. This at X. Line creates a box, labeled X, specifically for numbers. Imagine it like a magic box that captures information. This is where the magic happens. Scamp is like saying, "Hey user, tell me a number and put it in the box named X dot." But how does it know what type of number to expect? This %d is our secret code. It tells Scamp we're waiting for an integer, a whole number like 5 or 12. There are other codes for different types of information, like letters or words. And this $X symbol? It's the key that unlocks the box. It says, "Don't just look at the number, put it right inside the box named X." So, when you type a number and press enter, it goes straight into our program, stored in the X box. We can then use that number for calculations, display it on the screen, or anything else we want. Remember, this is just the beginning. There's a whole world of user input to explore. But for now, you've learned how to have your first conversation with your computer program. Isn't that cool? Now we're going to be talking about the ampersand operator in C programming. The ampersand operator, denoted by ampersand, returns the memory address of a variable. This means that when you use the scan function, it takes the input from the user and stores it in a particular memory address. This concept will be very useful when we start learning about pointers later in the course. Let's take a look at this code snippet. Here, we have hashtag include style.h. This line includes the standard input-output library, which provides us with functions like Scamp for user input. Next, we have the main function, which is the entry point of our program. The code within this function will be executed when we run the program. Inside the main function, we have an X. This line declares an integer variable named X to store the user input. Now we have the line scanned, %d, $X. This line is where the actual input happens. Let's break it down. Scan. This function reads formatted input from the standard input, usually the keyboard dot. %d. This is a format specifier, which tells Scamp to expect an integer input. $x. This is the address of operator. It passes the memory address of the variable x to Scamp, so the input value can be stored there. In simpler terms, when the user enters a number and presses enter, the Scamp function takes that number and stores it in the memory location of the variable x. We can then use the value stored in x for further calculations or operations in our program. Remember, the ampersand operator is essential when using Scamp because it tells the function where to store the input data. Without it, the input would be lost and not accessible to our program. I hope this explanation clarifies the concept of the ampersand operator and its use with Scamp in C programming. Alright, mathematicians and future programmers. Today, we're diving into the wonderful world of mathematical operators in C language. These are the tools that let us perform calculations and solve problems within our programs. Let's get started. See these symbols, plus, dash, asterisk, /%, and their friends? These are our operators, each with a specific superpower. Let's meet them one by one. 1. Addition, plus, and subtraction. These are the classics, just like in math class. Use plus to add, like combining apples and oranges, and to subtract, like taking a bite out of that apple pie. 2. Multiplication. Asterisk. Now things get exciting. Imagine multiplying cookies by friends to share the sweetness. That's what asterisk does, multiplying two numbers to get a bigger result. 3. Division, / sharing is caring, and division, / helps us share cookies fairly. Remember, it can't share by 0 though, just like you can't share nothing. 4. Modulus, %. This one's a bit trickier. Imagine having 7 cookies and dividing them among 3 friends. % gives you the remainder, so in this case, it would be 1 leftover cookie for you. Let's talk about two special functions, POW and SQRT. Can anyone guess what they might do? Great guesses. POW stands for power and SQRT stands for square root. These functions help us crunch numbers in unique ways. Let's see them in action. This code shows POW 2, 3, which calculates 2 to the power of 3. Remember order of operations? POW comes before multiplication, so it's like saying 2 by 2 asterisk 2, which equals 8. And here's SQRT 16. This finds the square root of 16, which is 4. It's like asking, what number multiplied by itself equals 16? Now, how do these functions work? POW takes two arguments, the base, the number we're raising to a power, and the exponent, the power itself. Inside the function, it multiplies the base by itself the number of times specified by the exponent. For SQRT, it only takes one argument, the number whose square root we want to find. The function uses clever algorithms to estimate the answer very precisely. Remember, these are just the basics. You can use POW for any powers, not just whole numbers.
Better this time. I thought I would never be fine. I strive just to say I'm alright.
And SQRT works for many numbers, even negative ones. Although the result might be imaginary, a whole different topic.
Through a lot of pain. Some things are not the same as they were a year ago.
So next time you need to calculate powers or square roots in your programs, think of these handy functions as your mathematical superheroes.
Back a year ago.
Now we're going to talk about the order of precedence in C programming. This fancy term basically means the order in which your computer evaluates different parts of a mathematical expression. It's like having a set of rules that decides which calculations to do first, second, and so on. See this table? It shows the different operators in C, grouped according to their precedence. Operators higher up in the table are evaluated first. So, for example, multiplication and division, asterisk, and / are done before addition and subtraction, plus, and.
Some things are not the same as they were a year ago.
Take this expression, 2 plus 5 asterisk, 10/5 by 2. Following the order of precedence, we first do the multiplication and division inside the parentheses. 10 divided by 5 times 2 is equal to 2 asterisk 2 is equal to 4. Then, we multiply 5 by 4. 5 times 4 is equal to 20. Finally, we add 2 to 20. 2 plus 20 is equal to 22. So, the entire expression equals 22. Remember, even if you're using the same operators, the order they appear in can change the answer. That's why understanding precedence is crucial for writing correct and efficient C code. Here are some additional points to keep in mind. Parentheses can be used to override the normal order of precedence. For example, 2 plus 5, asterisk 4 equals 28 because the addition happens first inside the parentheses. Some operators have the same precedence and associate from left to right or right to left. For example, multiplication and division associate from left to right. So 2 times 3 divided by 2 equals 3. I encourage you to practice using the order of precedence table and experiment with different expressions to solidify your understanding. I hope this is helpful. Now, we're venturing into the world of comparisons in C programming using relational operators. These operators help us answer questions like, is this number greater than that? Or, are these two strings the same? See this table? It lists the 6 relational operators in C. 1. Greater than sign, checks if the left operand is greater than the right operand. 2. Less than sign, checks if the left operand is less than the right operand. 3. Greater than or equal to sign, checks if the left operand is greater than or equal to the right operand. 4. Less than or equal to sign, checks if the left operand is less than or equal to the right operand. 5. Equal sign, checks if the left operand is equal to the right operand. 6. Not equal to is not equal to sign, checks if the left operand is not equal to the right operand. Remember, these operators compare values, not variables themselves. So, 5 greater than 2 is true, but x greater than y might be true or false depending on the values stored in x and y. Let's try evaluating age greater than or equal to 18. This expression checks if the value stored in the variable age is greater than or equal to 18. If age holds 20, the result is true. But if it holds 16, the result is false. It's important to note that relational operators result in Boolean values, either true or false. These values can then be used in control structures, like if statements, to make decisions in your program. Relational operators are versatile tools for comparing different data types in C, from numbers and characters to strings and pointers. As we progress, you'll see how they play a vital role in various programming tasks. Remember, the key is to understand what they compare and how they result in true or false values. Feel free to experiment with different expressions and values to solidify your understanding. Now we're diving into the world of logic in C programming using logical operators. These operators help us combine multiple conditions and make complex decisions in our programs. As you can see on this slide, there are 3 main logical operators in C. 1. Logical AND. And this operator returns true only if both conditions it connects are true. Imagine it as an AND gate. Only when both inputs are true does the output become true. Point 2. Logical OR. This operator returns true if at least one of the conditions it connects is true. Think of it as an OR gate. If either input is true, the output is true. Point 3. Logical NOT. This operator reverses the logical state of a single condition. If the condition is true, it becomes false, and vice versa. It's like a negation switch. It flips the truth value. Let's see these operators in action. For example, age greater than or equal to 18 and score greater than 80 would be true only if someone is both 18 or older and has a score above 80. On the other hand, grade equals a GPA greater than 3.5 would be true if someone either got an A grade or has a GPA higher than 3.5. Now we're exploring the fascinating world of unary operators in C programming. These operators work on a single operand, hence the uni part, and they can perform various transformations on their values. As you can see on this slide, there are 6 common unary operators in C. 1. Increment. ++ this operator increases the value of its operand by 1. There are 2 types surprise face. Prefix increment. ++ increments the value before using it. For example, ++ x first increments x by 1, and then uses the new value. O postfix increment. X ++ increments the value after using it. For example, x ++ first uses the current value of x and then increments it by 1.2. Decrement. This operator decreases the value of its operand by 1. Similar to increment, there are prefix and postfix versions with the same behavior. Point 3. Unary plus. This operator doesn't change the value of its operand. It's mainly used to indicate that the operand is positive 0.4. Unary minus, this operator negates the value of its operand, changing its sign. For example, -5 becomes 5. 5. Logical not. This operator reverses the logical state of its operand. If it's true, it becomes false, and vice versa. 0.6. Bitwise complement. This operator performs a bitwise inversion, flipping each bit of the operand's binary representation. Now we're focusing on two unary operators in C programming, unary plus and unary minus. These operators work on single values, and while they might seem simple, they have interesting nuances. As you can see here, the unary plus operator, plus, doesn't actually change the value of its operand. It might seem redundant, but it can be useful in certain situations. For example, if you have a variable x with the value 5, plus x is still 5. However, there are two key reasons why we might use unary plus. One, clarity. Sometimes, adding a unary plus can make code more readable, especially in complex expressions. It explicitly states that the operand is positive, even if it technically doesn't affect the value. Two, forcing conversion. In some cases, unary plus can be used to convert an operand to a specific data type. For example, if y is a character variable containing a plus y converts it to the numerical equivalent of in the ASCII table, which is 65. On the other hand, the unary minus operator negates the value of its operand. So, if z is 10, z becomes -10. This is straightforward for numerical values, but remember that unary minus also works with other data types. For example, negating a pointer changes its direction in memory. Here are some additional points to keep in mind. Both unary plus and minus have higher precedence than most arithmetic operators. So, in the expression a plus b, the unary minus is applied to b first, then the addition happens. Be careful not to confuse unary plus minus with the regular plus minus signs used in arithmetic expressions. They have different purposes and behaviors. Now, we're diving into the world of increment and decrement operators in C programming. These operators are handy tools for adjusting the values of variables by 1, making them essential for counting, loops, and various programming tasks. As you can see on this slide, there are two types of increment and decrement operators, prefix and postfix. Let's break them down. Prefix increment, plus plus, this operator increases the value of its operand by 1 before it's used in an expression. For example, plus plus x first increments x by 1 and then uses the new value. Prefix decrement, similar to prefix increment, this operator decreases the value of its operand by 1 before it's used. So, y first decrements y by 1 and then uses the new value. Postfix increment, x plus plus, this operator increases the value of its operand by 1 after it's used in an expression. For example, x plus plus first uses the current value of x and then increments it by 1. Postfix decrement, x similar to postfix increment, This operator decreases the value of its operand by 1 after it's used. So, y first uses the current value of y, and then decrements it by 1. Let's see these operators in action with some examples. Suppose x is 5. Then surprise phase plus plus x makes x become 6, increments first, then uses 6, dot ox plus plus uses 5 from x first, then increments to 6, uses 5, then increments, dot similarly. If y is 10 surprise phase y makes y become 9, decrements first, then uses 9, dot oy uses 10 from y first, then decrements to 9, uses 10, then decrements. It's crucial to understand the difference between prefix and postfix operators. They might seem like subtle variations, but the order of evaluation matters. Prefix operators change the value before use, while postfix operators change it after use. Increment and decrement operators are widely used in loops, conditional statements, and various calculations. They offer a concise way to iterate through values, update counters, and adjust variables efficiently. How can you imagine using them in your own programs? Remember, practice is key to mastering their usage. Try writing small code snippets that explore different scenarios and see how the prefix/postfix behavior affects the output. Now, we're exploring a helpful tool in C programming called the size of operator. This operator, as the name suggests, tells us the size in bytes of any variable or data type. Look at this line. Int size equals size of int. Here, size of is applied to the int data type itself. When we run this code, size will store the number of bytes an integer variable typically occupies on our system. This value might be 2 or 4 bytes depending on the architecture. Remember, size of gives us the size in bytes, not the actual value stored in the variable. It's important to note that sizeof doesn't work with expressions or complex data structures directly. It operates on individual variables or data types at a time. So, remember sizeof as your memory measuring tool in C. It helps you allocate space efficiently, understand data structures, and even debug memory-related issues. Okay, so now we have come to the last part of this Part 3 session. Now let's have the challenge questions. So, the first question is to take an input from the user and print the user input. The second question is to calculate the following expression and get the output. The third question is to calculate the following expressing using relational and logical operations. The fourth question is to give the output for the following 2 print statements. Now pause the video, then solve the problem. Now let us discuss the solution for the problem. For the question 1, first create the integer x, then use scan function to take the input. Now print the value. For the second question, the output will be 810. For the third question, the output will be 0. Now for the fourth question, the output will be 3 and 3. That's all for today's video. Now in the next part, we will see about the conditional statements like if, else if, nested if else, switch conditions, then at last we will be trying to make a simple calculator app, which will be our challenge 4. So if you guys are able to understand this video, then subscribe the channel for more updates. Thanks for watching. Peace.